Lesson 4, ready, set, go. We start with evaluating functions. That means replacing the variable with the number indicated in between the parentheses. So this would be 5 times negative 4 plus 8, or negative 20 plus 8, negative 12, our answer. Replace n in the function definition with 12. Negative 2 times 12 plus 1. That's negative 24 plus 1. Or negative 23. When you're working with a fraction, remember a fraction is just instructions to multiply and divide. So what we can do is 6 times 2, that's 12, and then divide by the 3. So 12 divided by 3, 4, 4 minus 3, answer is 1. The hidden number in number 4 is negative 1. It's negative 1 times n. That would be another way to say that. Or you could call it the opposite of n. So if n is now replaced with negative 6, negative n is positive 6. Number 5 is an exponent. So 5 to the 4th power, that's 625. And 3 to the negative 1. With the use of a calculator, you'll find that it's 0.3, and the 0.3 goes on forever. Similarly, number 7. So negative exponents, they actually mean reciprocal, which means to flip upside down the fraction. So you could say that this next one is 10 to the negative 2, or 1 divided by 10 to the second. See, there was a 1 underneath 10 to the negative 2 right here that you couldn't see. It's invisible. So this is 1 out of 100, 10 times 10. Or as a calculator would probably report it to you as 0.01, 1/100th. And 2 to the 0, I think this is the 3rd or 4th time we've seen a number to the 0 power. That is equal to 1. Okay, in our set section, we're practicing writing the common difference, the recursive function, the explicit function. These are all arithmetic, by the way. And by the way, there's also a hint here that the first number is n equals 1, not 0. So first of all, understanding the pattern is being able to complete it. The pattern here is to, every time we go to the next number, to add 4. And that is the common difference. So we're going to add 4. We'll just say plus 4. So that would make this 23, 27, 31. The recursive function is just that next equals previous plus 4. The explicit function we can develop from a formula. In an earlier video, I said that the formula is that f of n in an arithmetic sequence is the first number plus the common difference times n minus 1. So using that formula, f of n is the first number 3 plus the common difference of 4 times n minus 1. In the future, we may want to clean that up a little bit by using the distributive property, but for now, we're going to leave it like that. Number 10, the common difference is we're going down by 3. Now, there's a sure way to figure out what the common difference is. If you take any number in the sequence other than the first one, and you subtract the one that came before it, you will get the common difference. So you see 8 minus 11, also 5 minus 8, also 2 minus 5, and so on and so on and so on. So you can see that this is going to go to negative 4, then negative 7, then negative 10. The recursive function is simply next equals previous minus 3. And the explicit function is f of n is the first number, 11, and then we can go ahead and just write minus 3. We don't have to write plus a negative, and that's n minus 1. And we'll leave it like that. 11 has a little challenge to it. It has a decimal, but no problem. Just do 2 minus 5 minus 4. 2.5 rather, minus 4. You get negative 1.5. So we're going down. This will be negative 3.5, negative 5, negative 6.5. The common difference, negative 1.5. The recursive is next equals previous minus 1.5, and the explicit function. The first number, which was 4, minus common difference, so 1.5, n minus 1. Our last problem. Any number, remember any two numbers except the first one, so 24 minus 36, negative 12. We're going down by 12s every time. Down, 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 down. So 12, 0, negative 12. Common difference is negative 12. Recursive function is next equals previous minus 12. Explicit function, first number, 72, minus 12 times n minus 1. All of these have n minus 1 for a very special reason. The reason is, it was here at the top, the first number is n equals 1, not n equals 0. So we're having to make an adjustment, and that's the adjustment. In our Go section, we have some graph reading to do. Olaf's climbing a mountain. His elevation is changing throughout the day. Here's the graph. And the questions, what was Olaf's elevation at noon? That's right here. He was at 9,000 feet. Next question, what was his elevation at 3 p.m.? He came down here too, as you can see as you read across on the graph. He's at between 4,000 and 5,000. He's at 4,500 feet. How many feet had Olaf descended from noon until 3 p.m.? That would have been a total of 4,500 feet. The same as his elevation. So basically, it's because he went halfway. Olaf reached the base camp at 4 p.m. What is the elevation of the base camp? Find the dot, find the number 4 p.m., and then just read directly to the left. 1,000 feet. During which hour was Olaf descending the mountain the fastest? Explain how you know. He was going down the fastest between 3 and 4 p.m. Because look how far down he went. He went down from 4,500 to 1,000. In 1 hour, he went down 3,500. The other times were not nearly as steep. See, between these 2 points, same 1 hour, he only went down 2,500. And, here approximately 1,000-foot drop or so, 1,000-foot drop. So definitely, for example, if you connected the points together, this is the steepest drop right here. So what this is really getting at is it's getting at the concept of slope. Does the value of f of n represent the time or the elevation? It's the elevation. So on this graph, f of n is the y-axis and n is the x-axis. So of these other review questions we had here, in my class we stopped at number 19. We didn't do the tables or the points today because I just wanted to point out that if you have a graph and you go between any 2 points that are at a nice intersection, like for example, here's a nice intersection. So it's where the graph and the line all come together. Here's another one right here. You make what's called a slope triangle. You can make a right triangle off of those points and then do some counting. So you're counting up 1, 2, 3, 4 squares this way, and 1, 2, 3, 4, 5, 6 squares that way. Remember we said last week that the change of y and change of x is how we define slope. So we're changing 4 and we're changing 6. 4 over 6, or as that reduces, 2 over 3, that is the slope of this line. See you next time.